Happy day, this is Angayarkanni, M.O.P Vaishnav College for Women. Today we will see the topic on data structure. What is data structure? Why we need to choose a proper data structure, and what is the benefit of choosing a proper data structure, and few example of data structure. So, data structure is a way in which we are going to organize, retrieve and access the data. Data structure consists of set of data, domains and set of operations that can be performed on the data. So, data structure is nothing but it is a triplet which contains the data, the rules to be followed and the operations to be performed on the data. So, what are all the various operations that can be performed on the data are traversal, insertion, deletion, updation, modification, searching, sorting and merging. So, traversal is nothing but performing a particular operation on all the data stored in the data structure. Insertion is adding an element to the data structure, deletion is removing an existing element from the data structure, merging is you can merge two data structure which contains data structure of same type which contains the data. Searching is searching for an element which is available in the data structure or not. Sorting is arranging the elements in the ascending or descending order. So, what is the benefit of choosing a proper data structure? It enables efficient access and manipulation of data. It is essential to build fast, reliable software, and it helps to optimize algorithms so that the performance of the algorithm can be increased, and it is the fundamental building blocks for designing an efficient algorithm or a program. How to choose a proper data structure is you have to analyze the problem requirement, understand the problem requirement, consider the data type and operations that can be performed on the data, analyze the trade-off between different data structures so that you will get an idea of which data structure will be appropriate for your application. And you have to consider the following factors such as data ordering, retrieval needs, memory usage and execution time requirement. So, we will see an example of data structure. For example, you take water as the data and the container to store the water as the data structure. So, suppose you want to carry water to school or college, it is best to choose a water bottle. You cannot, in that case you cannot take a bucket or a pot. So, which will be apt for you? You will take a water bottle. Suppose you want to take the water, you will just lift the water bottle and have the water. The same thing, suppose you want to use the water for cooking, you cannot use the water bottle, you can use it, but there is a limited amount of water, you want to use more water. So, what you will do, you can store the water in the pot and use it for cooking. When you cook, you cannot take a pot and pour the water into the vessel. So, you will make use of a cup in order to fetch the water and use it. So, in the previous case also your data is water, in the second case also you are using water, but the container in which you are storing the water is going to be different. Why it is different? Because water bottle, taking water bottle is easy for you to carry to college, whereas carrying the pot is not easy. Similarly, why you are choosing pot to cook? Because you want more water. Similarly, I can give you two more examples. Suppose you want to mop the floor, you can take the water in the bucket so that you can insert the mop stick and mop it. Suppose you want to use the water for multiple purpose such as washing the vessels or other purpose, watering the plant. In that case, you will require a large amount of water. So, you are going to fetch the water from the tank. How do you fetch it? Using a pipeline, you can take the water and you can use it. So, how do you measure the efficiency of an algorithm? You can, for a given problem, you can write more than one algorithm. Suppose you want to sort a set of element, either you can use bubble sort or quick sort or merge sort. But given the same input, you are going to get the same output. How do you say that one algorithm is better than the other? So, here only measurement or efficiency of algorithm is needed. So, how do you measure? You measure the algorithm efficiency based upon time and space. So, either you can reduce the time requirement or you can reduce the space requirement. Always there is a trade off between the space and time. If you want, you cannot reduce both. So, if you want to reduce the memory space, definitely the execution time is going to increase. If you want to reduce the execution time, you have to increase the memory space. Now, you can classify the data structure into two types. One is going to be primitive, the other one is non-primitive. In primitive, you have integer, character, float, boolean, which is by default available in your programming language, whereas non-primitive is using the basic data type, you can arrive at your non-primitive data structure. Example is array and list. In list, you can categorize as linear, non-linear. Linear is going to be stack, queue, linked list. and non-linear is going to be tree and graph. So, what is the benefit of, you can, when do you use an array? Suppose you want to store the data element in continuous memory location, you go in for an array, and array is used to store homogeneous data type. Homogeneous means same type, either all integer or all float or all character. And one of the application of array is, it is used in image processing. Then you can use stack. Stack is a linear list in which insertion and deletion is going to take place at one end, which is going to be called as the top. If you see, evaluation of expression and all takes place with the help of stack. It is the application, most important application of stack. Similarly, it is used in recursion. Coming to the next data structure, which is a queue. Queue is a linear list in which insertion takes place at one end called the rear, and the deletion takes place at one end called the front. If you see, task scheduling in OS takes place with the help of queue. The next one is linked list. When do you go for linked list? Suppose you do not have contiguous memory location, you have scattered memory locations available, means you can go in for linked list. But how is the ordering of data element is available is by means of pointer. So, you need extra space in order to store a pointer. But here, if you use linked list, insertion and deletion can be done in any place. Tree is a collection of element which is going to represent hierarchical relationship. One of the application of tree, if you see, it is your file system is maintained in Unix, your file system is maintained as a tree, and you can even use the trees are used as decision trees in machine learning. And if you see graph, graph is also equivalent to tree. The difference between graph and tree is, in tree you will not have a cycle, whereas in graph you will have a cycle. One of the most important application of graph is social networking and routing algorithms, which is used by Google Map. So, here the pictorial representation of all the data structure has been given: array, linked list, stack, queue, tree and graph. So, what and all we have seen is the definition of tree, the definition of data structure, its application, and why we need to choose a proper data structure. So, in order to build an efficient algorithm or program, definitely you have to make a good choice of your data structure. Thank you.